Coming up, I stretch some bolts and myself, we fix a purse.
Why am I confused by this?
And we go from a bare block to a fully assembled engine.
Hello and welcome to part 4 of Project Chicago, the engineless Alpina B7. In case you missed previous episodes, I highly recommend you go back and watch them, otherwise most of this is not going to make any sense. But in short, I bought this giant check engine light for just $4,000 from a subscriber in Chicago, and at first glance it seemed like it's not going to need a lot of work. It came with the check engine light, which I know it's surprising, you never see that on these cars. And we found that the timing was off. Then we found that one of the timing chain guides was broken, so we started replacing the timing chain guides. Then we found a nail in the oil pan, which is only slightly unusual, because that's where you expect to find nails. And then I decided to look inside the cylinders, and we found 2 cylinders that were scored. And then I made an executive decision and decided to take the engine out of the car and disassemble it completely. So we left off with the block completely stripped and me considering the options. How are we going to fix this thing? Well, the option has been picked, and inside are refurbished parts. So let's take a look, and it's time to build the engine for this thing. Oh, in case you're wondering what these stains are, it's oil. It's always oil. Behold, refurbished Alpina H1 engine parts. This is the block and the culprit, the whole reason why I had to disassemble this entire engine. We had scored cylinders number 1 and number 4. The rest of them didn't look that great either. And I had essentially 3 options here. The first one was to hone the block, but this is alloy seal. You can't really hone it unless the scratches are really minimal. Here they were too deep, and Huey's Garage actually tried to do that with his B7, and unfortunately it didn't work out, and he ended up junking that car. So that was not an option for me. Second one, simply buy a brand new block. And I did reach out to Alpina, new block, it's 5,000 euro, and with that you have to get new piston and piston rings, that's another 3 grand, and you end up with 8,000 European shillings in just 2 components. And then there's everything else. It just didn't make any financial sense to go down that route because the car is not worth it. And I was also told by Alpina that their precious car shouldn't be repaired like this, by me, outside authorized dealer network. Well, we're gonna fix it anyway, which brings us to the third option, and that is to sleeve this block. And that's what happened here. We're gonna talk about that more in a bit, but first let's take a look at the rest of the parts. Both heads completely refurbished now, but as if I needed further validation that this thing needed to be taken apart, the machine shop actually found 6 bent valves. That was a bit surprising because the engine was still working fine, it wasn't smoking, the compression was good, but then on the other hand, it did skip timing 2-3 times, maybe even more. So in the end, it kind of did make sense. So now we have brand new valves here and there, new valve guides, new valve stem seals, and both heads resurfaced. And this is ready to go back in. The crankshaft, thankfully in good order. It was only lightly polished, and now we just need to clean it, and it's ready to be used. The pistons also cleaned, checked, measured, and then custom sleeves made for them, and making sure that all of the piston to valve clearances are on point because you have to account for use of different metal. These are now cast iron sleeves. All we have to do here is clean them again, slap new piston rings, and they're ready to go in. Now, coming back to the block, sleeving this thing was probably the best and strongest option here, short of going with Nickel coating, which is just a completely different territory. But sleeving the block is something that many can try, but not everyone can do properly. And the best quote for it that I got here in Germany was 3,200 euros, which is actually a pretty reasonable price for German standards. But I ended up talking to a friend back home in Serbia, and he had his S62 block sleeved, the one in E39 M5, by a machine shop there, and that car has been running for around 50,000 kilometers over the last 5-6 years, and he hasn't missed a beat. So he put me in touch with the shop, and I ended up talking with the guy for a long time. He explained everything to me, and turns out he's sleeving alloy seal blocks all day long. He's done a ton of N62 engines, N63, M62, S62, loads of different BMW engines, as well as Audi, Porsche, all of those alloy seal blocks. So he definitely knows what he's doing. I saw pictures of his work, and that combined with the experience from my friend, it was enough to convince me to send him all of the parts to be refurbished. And here's the kicker, because labor is stupid cheap in Serbia, it cost me 600 euros to sleeve this thing. Pretty unbelievable. Then 100 euros per head to refurbish them, another 100 for miscellaneous parts, valves, polishing the crank, and all in for a service and work, 900 euros. I also pay 350 on shipping, but when you total it up, just a killer deal to save this engine and that car. And now we have one beautiful Alpina H1 block that's been sleeved and it looks just exquisite. I mean, look at those sleeves and cross hatching. It looks absolutely beautiful. I am very happy with the work, and thanks to Nenad, this engine has been saved. Now I need to start with the reassembly. This is just one of many piles of parts that I need to unpack. And then we're gonna start this and do it step by step because I want everything to make sense to you as well as for me. And then we need to double check, triple check everything and put this thing back together properly, because it's not just slapping parts together. You need to know what you're doing. And once you assemble it, it's either gonna work or not. So there's no going back. We can't make any mistakes here. And with that, let's start. First order of business, reunite the crankshaft with the block. That means we have brand new main cap bolts, old main caps that we need to clean, and brand new main bearings. When it comes to bearings, we have 3 different flavors: green, yellow, and violet. And what that means is different clearance. So how do you know which bearings this engine uses? That's actually quite simple. When they assemble this engine in the factory, they measure all of the clearances and then they pick appropriate bearings. So for the upper bearings, the ones that live in the block, we have all green bearings, and that's actually stamped on the top of the block itself. For the lower bearings, the ones that reside in the main caps, we have 1 and 2 green, 3 is yellow, 4 and 5 green, and that's stamped on the crankshaft itself. We're also going to use plastic gauge to check for clearance. This isn't something that we necessarily need to do because we're using exact same parts, but it is a good practice, and I just want to make sure that everything is still within spec. So now I'm going to start cleaning all of this, and then we're going to start putting it back in dry so we can check the clearance. You can't use any oil that can give us false readings. Then we need to remove everything, do another round of cleaning, and then everything goes back in for the final time with the assembly lube. Clean the caps. To remove the bearing, just wiggle it out. And then we're going to use brake cleaner. And then fine Scotch-Brite, just to make sure there's no residual stuff left behind from the old bearing. So now wash it out with brake cleaner and then blow it out with compressed air. Thread in these support bushings. All of the caps are stamped. This one is number 3, which means we're using this yellow bearing. There's a notch on the bearing here that we need to line up with the notch on the cap, like that, and then just push it in. And this one is ready to go in, so put it on the side. And that's all 5 main caps ready to go in. Now we can focus on the block. So final wipe here, it needs to be oil-free. Now I can start putting in bearings. It goes 1 to 5. So same deal, line up the notch and then just make sure this is sitting flat in there with this surface. Now I need to thoroughly clean the crankshaft, and I'm going to use this thing. I believe this is from my coffee machine. It has these soft bristles and it goes in perfectly to clean the oil channels. You don't want to use anything metal in here, just some soft plastic, nylon, whatever this is to clean it. All right, this is now clean and ready to go in. A wipe, a little bit of silicone spray here, so it's easier to remove. Plastic gauge instructions say to use grease, but silicone spray is nicer, easier to remove, and it's also not gonna mess with the readings. So that's a strip of plastic gauge in place. I also put a tiny bit of silicone spray onto the bearing, again, to remove plastic gauge easier. So cap number 1 going in, and you also have to pay attention that this notch here is pointing towards this side of the block. And here we're using old bolts because these are one-time use bolts. Therefore, we do not want to use new bolts to check the clearance. And I've coated them lightly with fogging oil from Men. Good. Now it's time to torque. I give you the main weapon for this job. My man Philip, subscriber, Patreon, and a very nice person, sent me a Hazard digital torque wrench. It has Newton meters, of course, but it also does torque angle, which is going to come really useful when assembling this engine. And it comes with this, so you can torque whatever, wherever you want. So let's fire it up and torque the main cap bolts. The torque is first 20 Newton meters and then 100 degrees angle. All right, so 100 degrees angle. That's 100. Yep. First, we're gonna loosen them. Get the caps off. The repair manual for this engine specifies that the clearance for the main bearing should be between 0.024 to 0.052 millimeters. So that's what we want to see here. That's 0.50. You can see it's definitely not too loose, but a bit wider than 0.50, so something in between 0.50 and 0.38. Plastic gauge is not going to give you an exact number, but just a ballpark so you know you're within specification. In this case, we have about 0.050, and that's within spec, and we're good to go there. Journal number 2, something in between 0.050 and 0.038. But again, we don't need a precise number here. We just need to know that we are within specified clearance. Journal number 3, also within spec. Numero 4, also within spec. And number 5, also within spec. Now we need to remove the plastic gauge. For that, we're just gonna use oil and fresh carbon fiber towel. Perfect. Silicone spray did its job. We barely have anything left on the bearing, and we really don't want to scrape or rub that too much. So just a little bit of oil to remove that, and that's it. Now I'm going to remove the crankshaft so we can put assembly lube on the bearings. So gingerly. And now a very clean finger. A nice thin layer onto the bearing and nowhere else. These spots need to be oil-free. You can also use engine oil, but since we're going to be turning this engine over 15 million times, I prefer to use assembly lube. I gave the crankshaft another nice wipe, just for good measure. Now I'm gonna do fogging oil from Men there. Now we're gonna apply some engine oil. Crankshaft going in for the final time. Beautifully executed. I'm also replacing the support bushes. So thread them all the way in. Clean finger. Now brand new bolts. The repair manual specifically states not to remove the coating from the bolts. For the initial torque of 20 Newton meters, we're going to use a good old click torque wrench. We need that satisfying click sound. Now we're going to remove the bolts on the 5th main cap, and then we're going to hit the crankshaft front and back with a rubber mallet, and that way we can align the thrust bearing. We're not going to go crazy here, just lightly tap on the back of the crankshaft and then the front. That should be it. Put back the bolts. And that's the main cap bolts torqued. The crankshaft should turn absolutely smooth now, without any resistance. Sure does. Lovely. Now we're going to torque these support bushings. These are torqued very lightly to 6 Newton meters. This one barely clicks, but you won't be able to hear it. Nice. Now we have 4 brand new flange head screws. The rest of them, that's where the oil pump resides, and that's going to come later. And that's as far as installation of the crankshaft goes. Nothing too complicated. Just got to know what you're doing and follow the repair manual to the letter. Oil spares for the pistons. These are the old ones. Nothing wrong with them. I just thoroughly cleaned them. And this is the one for the timing chain. And there I went for a new one because this has the small regulating ball thing, and it just made sense to replace it. Right, now I can start with the pistons. Short interruption of the program. No, I haven't started promoting bags or fashion accessories. This is my girlfriend's bag. Has a bit of an issue, and I promised I would fix it, so we gotta do that. This particular unit is made by Valentino. I think he's a famous dancer or something. Doesn't matter, but this is a handle, I believe, and this thing used to go here, and then there was a bolt securing it like that. Well, the bolt fell out, and now she can't carry her lumber material and other construction stuff. So I found a bolt. Oh, we only need one. In the software store, and that should work. Why am I confused by this? Look at that. Only that looks kind of ugly. Don't think she's gonna like that. So I'm gonna screw that in, chop this up, and that way when I screw it in, it's not gonna stick out. Ooh, that's hot. And then I think I'm gonna do like a slot. That way I can use a flat-headed screwdriver to drive it in. Yeah, that should work. First class, my man. First class. Look at that, perfectly flush. Now we need to spritz it up. Got some gold paint to match, well, fake gold. Where's my paint booth? Ooh, that's sparkly. That actually matches kind of decently. I'm gonna put a little bit of green thread locker into the hole so that never comes off. Look at that. Mr. Balboni himself would be proud. All right, with that exciting stuff over, let's continue with the engine rebuild. Since the next step is to rekindle the spark between the pistons and the block, we gotta talk about the piston rings. As mentioned earlier, we are reusing old pistons, and unfortunately, original rings for them are no longer available. You can only buy them together with new pistons, and as we are not doing that, that meant I had to do a bit of research to find compatible piston rings. First thing we have to keep in mind here is the material of the piston rings and what's compatible with the sleeves that we have now. This is an alloy seal block which requires rings made of compatible materials, and pretty much all B&W piston rings in the last 20 years or so are meant to work in alloy seal cylinders. But we no longer have that. Now we have cast iron sleeves, and as I didn't study metallurgy, I had to read up on this matter and talk to the experts in the field. The bottom line is this: you can use without any issues alu-sealed piston rings in cast iron sleeves. I confirmed this with Mahle technical department in Stuttgart, then a small shop that makes custom piston rings, and like 3 different machine shops. However, if you're using steel sleeves, then these won't be compatible and you have to find different rings. Here we have new rings. The top compression ring and the oil control ring are from Mahle, and they are nitrided, which is a heating process meant to increase surface hardness, wear resistance, fatigue life, etc. The middle ring is from Goetze, and this is a graphite cast iron ring. I'll explain in a second why I had to mix and match. So we have compatible rings with our sleeves. The next important thing are the dimensions and that they fit properly on the pistons. Here you can see measurements of the old original rings that I took with my precise Japanese caliper. This is the width, radial thickness, and diameter. The first and third ring from the Mahle set that I dug up in the parts catalog matches exactly, but the second one doesn't. The radial thickness of the new Mahle ring is 3.4 millimeters, if memory serves me right, and the original one is 3.9. That means we can't use it as it would have excessive play in the piston groove. So after more digging, I found the second ring from Goetze, and that is an exact match. So with that part sorted as well, the next very important thing is the piston ring gap. If you have a gap that's too big, that can result in loss of horsepower, blow-by, oil consumption, etc. If you have a gap that's too small, when the engine is under heavy load, the ring will expand, and if these two ends touch, it will put more force on the cylinder, create excessive heat, expand the ring further, and lead to catastrophic failure. Scored cylinder, breakage of the piston or the ring. Either way, not good. Even though I'm using a repair manual for Alpina B7, it doesn't specify gaps for the H1 engine, but only N62 engine, which is the block it's based on. As this is a supercharged engine, the general rule of thumb is to run slightly larger gaps, as forced induction adds significantly more cylinder pressure, which translates to more heat. So I checked the gaps of the original rings and confirmed that Alpina kept that in mind, as the gaps are on the limit or slightly above them to those of the naturally aspirated engine. I already measured the gaps for the second new ring on all 8 cylinders, and we are within spec. What I mean by this is that the feeler gauge was a bit too loose at 0.40 and a bit too tight at 0.45, so I marked it as such, something in between. The third ring, you can't really measure the gap because it's a 3-piece oil control ring, but I did chuck it into the cylinder just to make sure the ends are not touching or overlapping, and got these measurements. For the new first ring, I got a gap of 0.20 millimeters across all 8 cylinders. And while that is within spec for the N62 naturally aspirated engine, I want to err on the side of caution and enlarge that gap just like Alpina did. I completed that task on these 3 cylinders, and now we're going to do the rest of them together. Lube up the cylinder, the ring as well, and then gently insert it. Like that. Now I'm going to take this piston and push the ring inside. We want to do that to make sure that the ring is sitting leveled with the cylinder, otherwise we can get wrong readings. So push it in just a little bit in. I usually do it like that. That way I know these both sides here are leveled. Then we take our feeler gauge. We're going to start with 0.15. And that fits in easily. Then 0.20, and that fits as well. So we have a gap of around 0.20 millimeters, and we want to expand that to about 0.25, maybe even 0.30. More oil, and then we can slowly pull out the ring. You don't want to put too much pressure or stress onto the ring. This is the tool for expanding the piston ring gap, and it actually works quite simple. You turn the handle, it turns the grinding disc, and you remove some material from the ring to expand the gap. There are, however, a few important things to keep in mind. We're going to turn this handle from outside to in. Gonna do it at even, steady pace, not too slow, not too fast. We're only going to grind one side of the ring, and it's very important to keep it perfectly flat, parallel to the grinding disc. You don't want to grind at an angle that will ruin the ring. And I'm going to use my left hand to just hold it in place and keep it from vibrating, because we also don't want that, but I'm not going to push it in aggressively. And then once I feel I removed some material, I'm going to chuck it back into the cylinder, check the gap, and if necessary, repeat that process a couple of times until we achieve the desired gap, because I also don't want to remove too much material, then I can't use this ring. And also be sure not to drop, chip, or damage this in any way, because then we can't use it. So with a boatload of information in my head, let's start. Clean the shavings. All right, now I'm gonna put it back into the cylinder just to check. 0.25 still doesn't fit. Tiny bit more. This unfortunately takes a very long time. Winner, winner, chicken dinner. After I'm done grinding, I also take a very fine sandpaper, like 2000 or something, and just do a couple of swipes to make sure there's no sharp edge left. So here's where we're at, 0.25 filler gauge. Goes in nicely. So that is a gap that we want. And when I try 0.30, it can't fit. So that's the process. Tedious, slow, time consuming, but do it right, do it once. Task completed, all within spec. Now we can move on and start cleaning pistons, installing new piston rings and pistons back into the block. On this particular engine, all of the pistons and rods are labeled. You have a stamp here, as you can see on the piston, it says cylinder number 1, and then also here, number 1 between the rod cap and the connecting rod. So this one goes into cylinder number 1. Now I'm going to remove the rod cap, and these are forged connecting rods, meaning they're forged from one piece of metal and then they're cracked from the factory. So each cap and the connecting rod are unique, and you have letters stamped on the cap, in this case FS on the cap and FS on the connecting rod. So you can't mix and match. As you can see, you have this jagged edge, and this is why you can't mix and match them, and also why you can't drop them. If you drop them and damage them, throw them away. To remove the bearing, and now I can start cleaning. So I'm going to use Scotch-Brite to make sure everything is clean here for the new bearing, and there's no old material left behind. And then this edge here, we do not touch, just rinse it out with brake cleaner. And that's nice and clean. Now I can start removing old piston rings. For installation and removal of piston rings, we have these special pliers. And this is a very good tool because these ends here actually keep the piston ring from deforming and over stretching, where you can still open it and then slide it into the piston groove. This is the old one. Remove the first one. Like that. And then the third one we can do by hand. Nice. Now it's very important to clean piston ring grooves, and I'm actually going to put the rod cap back on while I'm manhandling the piston. See all of that stuff in the groove? We need to clean all of that. To clean the piston ring groove, I have this plastic scraper and a plastic brush. That's pretty clean. I'm gonna go wash it out. Now we're gonna lubricate the pin. And all of the grooves are now nice and clean, and the whole piston as well. Find the box. This is number 1. That'll be this one. This is our top ring, middle ring. First, we're gonna fog up the piston. So first, we're gonna install the expander for the old control ring, and there is a way that you install it. It is important that these ends do not overlap like that, but rather only touch like that. If you overlap them, then the ring is gonna snap. So we're gonna position the ends like here in the middle. And now the rails, we need to coat it with oil. Now we're gonna install the bottom rail, and we're gonna offset the end of it about 45 degrees from the end of the expander. So we're gonna put it somewhere around there. Now the top rail, and we're gonna offset this one 45 degrees in opposite direction. Just like that. And now we need to verify that the expander is not overlapping with anything, only that the ends are touching, which they are. So now we can move it just to make sure it's moving freely, not binding or anything like that, because the ring needs to be able to move in the groove. Now the middle ring, which we also need to coat with oil. And again, this ring needs to be able to move freely in the piston. And then the top ring. Nice and easy. And now we need to offset all of the gaps by around 120 degrees. So essentially like a Mercedes sign. So the middle one we can put there. And the top one. So the top gap is here, middle gap is here, the expander on the bottom is here, and then we have the rails offset 45 degrees off each other. So now we're gonna coat the piston with oil, especially the skirts. I did forget to mention the orientation of the piston rings, which is very important. For example, the middle piston ring has the top mark on it, and that means that the top needs to be pointing towards the top of the piston crown. The top ring didn't have any marks that said top, but it did have male marks and whatnot. And generally when you have writing like that, you're just pointing towards the top of the piston. The third all rail control ring, you can put it either way. It doesn't have directional orientation. And now the way that we install this piston back into the block, you can see an arrow here pointing that way. That means this piston goes into the block exactly like this and pointing towards the front of the engine and the timing chain. There are also dates on the rod caps, and on the cylinder number 1, on bank 1, it needs to be pointing like that towards the front of the engine. On bank 2, it needs to be pointing like that. And now with all of our gaps spread evenly, we can grab our piston ring compressor, which is this thing, coat that with oil, loads of oil. And now we're gonna put it over the piston, and then that way we can compress the rings. So also make sure that this end doesn't come over the gaps of the piston rings. And tighten it. And now I'm gonna take my soft rubber mallet and smack it a couple of times to expose the skirts. Like that, and then we can install it in the block and we know it's gonna line up. Then we have brand new rod bearings, upper and down original stock bearings, and I also bought this original B&W tool from the dealer. This is all plastic and it's gonna help us guide the connecting rod in the block, because if these edges touch the crankshaft, it can damage it and then it's game over. This gets mounted like that, and since it's plastic, it can't damage anything. This actually wasn't that expensive, around 80 euros, and it's gonna come in handy for whenever I do rod bearings. And all of the original parts, including this tool I got from Autohaus Melkus from Dresden. Daniel, who's a nice subscriber, works in the service department there, and he kindly made me a nice deal on all of these parts. Thank you very much. And don't worry, we're gonna do a cost breakdown at the end of the project, but it's already a lot of money. Now we're gonna install the upper bearing. This is all now dry, nice and clean. And installation is quite simple. You have to line up this notch here, like that. And then just push it in. That's it. Then this nice tool, which is also going to prevent rod bearing from dropping out when we install the piston. So not too tight, just lightly. And then this one gets clipped in. Nice. That looks interesting, doesn't it? Clean carbon fiber. Just remove all of the dust and stuff that's in the cylinder from it sitting. And now fresh oil, plenty of it. Piston numero uno going in. We are paying attention that the arrow is pointing towards the front of the engine. All right, and then I'm going to take my light rubber mallet and make sure that this thing is sitting flush. And then we're going to lightly tap onto the piston until it goes all the way in. Easy as that. Piston is in and we didn't snap or damage the rings. So the crankshaft is clean and oil free. We're also going to use plastic gauge here. Oh, this stuff works great. Pull it up all the way. Now the rod cap, remove the old bearing. And then same process to clean it. Bit of Scotch-Brite. Rinse it out with brake clean. So you have a part number on the rod bearings as well as saying it's standard on them, and that's how you know which bearings you're supposed to use here. Clean gloves. And gently install the bearing. Make sure this is flush as much as it can be. We're going to put this cap on the side for now, and we're going to go ahead and install the piston on the opposite bank on the same journal, and then we're going to use plastic gauge and check for clearance and torque both caps at the same time. Now we're going to prep the following piston. Keep it here. Install the bearing. Here it is. Bit of silicone spray. And now we're going to use old rod bolts. And of course we need to make sure that we are putting this correctly. So this is why we are torquing two caps at the same time. If you only have one, then this can slide on the crankshaft, and when you're torquing, you can distort or twist the conrod and then jam the bearing into the crankshaft. Probably won't do anything, but it's better to be on the safe side because when you have two, these cannot move as much and you can torque them properly. So the tightening torque for the conrod bolts is first 5 Newton meters, then 20, and then 70-degree angle. So we're gonna start with 6. Because that's the lowest setting I have on my torque wrench. Now we can loosen them. Rod bearing clearance for this engine is from 0.028 to 0.070 millimeters. So here we have something that's slightly wider than 0.050, but not as wide as 0.038. So something in between. But as I said, plastic gauge is not gonna give us a precise number. It's just gonna give us a ballpark, and we know that we are within the spec, which here we are definitely. And then the other one, same dealio, slightly wider than 0.050. So the wider the plastic gauge gets squished, the less clearance you have. The narrower it is, more clearance you have. So I wrote down the measurements. Now I can remove plastic gauge. All right, next step, we need to push back the pistons and the connecting rod, and then we can put assembly lube on the upper bearing. Just make sure we clear the crank. Enter a very clean finger. Very good. And that bearing is lubed up. Brand new carbon fiber towel. Now we're gonna coat the crankshaft with oil as well. And that's the other one up as well. The lower bearing lubed up as well. And again, gotta make sure we're putting everything back together in its original position. Brand new rod bolts. These are one-time use. You cannot reuse the old ones. And repair manual says to lightly coat them with oil. So I just do that, then wipe the excess off. Lovely. Try to do it in one nice sweep motion. Oh yes, everything needs to move smoothly without any resistance, just going up and down in perfect, beautiful motion. And from here till the end, it's all rinse and repeat. Same procedure for everything. Excellent. And with that, ladies and gents, the bottom end has been assembled. All of the pistons, rod bearings, main bearings, crankshaft. So if we've done a good job, this thing should spin effortlessly without any resistance whatsoever. And once you know it, pistons are dancing beautifully. Rotisserie Chicken 2.0 is a go. Beautiful, huh? Spins so nice and smoothly. Imagine this at 7,500 RPM. I gotta admit something. This was really fun, really interesting. Hopefully for you as well. I went really slow, took my time, made sure that everything is put back together properly. And now we have one beautiful Alpina H1 block. So let's quickly reflect on the data that we have. Here are the final results, and thankfully everything is within specification. But again, these are not exact measurements. We used plastic gauge, which is just going to give us a sanity check essentially, so that we know everything is within spec and we can proceed further. But if we used a brand new crankshaft or a brand new block, then we would have to use proper tools and measure everything and then pick appropriate bearings. But in this case, we just reused all of the old parts and we went with stock parts that factory recommended. So this is gonna go into the glove box of the car, and now we can proceed and install the oil pump. Here's a brand new oil pump. If you remember, when we disassembled the engine, I also took apart the oil pump for inspection. It had some wear and tear, and I decided to go with a brand new unit. The new pump doesn't come with this plate, so I just removed it from the old one, cleaned it up, and now we can bolt it in. And I don't want to blast this because it's very thin metal and I can actually damage it. Then a brand new gasket here. I'm gonna lube it up. The small pipe goes here. First we need to install the O-ring. So the pump comes with a brand new O-ring there, the big one. There's an O-ring there where the pipe goes in. Perfect. More oil, and then the pipe can go in. We have a brand new Valipan coolant pipe. We need to replace this O-ring here. New O-ring. A little bit of silicone grease. Gotta clean up this area here as well. Gonna do a bit of silicone spray on this O-ring here, and then we have silicone grease on the back. Beautiful. Before we can start reinstalling the heads, we need to put back the lower timing cover, and that means it's time for new timing components. We have new chains, new guides, and these are all genuine parts. I couldn't find OE ones, and I didn't want to go with aftermarket here, so original it is. The repair manual is not giving me any torque specification for these guys here, so we're just gonna go with good and tight. Lube up the O-rings. New oil pump chain. There it is. Gonna put a little bit of strong thread locker. Don't want that nut coming off. The nut is torqued to 45 Newton meters. Let's see if I'm gonna be able to do it, because I think I'm gonna have to lock up the engine somehow, because I can't counter hold it on this bolt. Oh, that was 45. Yep. Nice tension. It's time to clean up the lower timing cover, which means we need to deploy my Aquablast cabinet from Vixen Surface Treatments. You're already familiar with this. This is a vapor blaster cabinet. My favorite machine in the shop because it makes parts look better than brand new. So let's make that timing cover look really pretty. See? Not looking very pretty. There it is. It's phenomenal. We have the new gaskets here, new guide. we're going to install now. This goes there. Bolts have been cleaned as well, and we're ready to install the timing cover. Alternator bracket bolt goes through here, so we're not missing a bolt there. That's going to come later. The torque for this is 21 Newton meters. Finally, time to reinstall the cylinder heads. We have a brand new head gasket, new head bolts, washers, and little dowels that go into the block. So now we're going to start prepping the surfaces. Crucial that the surface is perfectly clean. So it's important that these holes are oil and dirt free. So I'm putting some brake cleaner in there, then agitating, and then using some Q-tips to absorb the brake cleaner. Look at that. That was in the hole. So all of the holes are now thoroughly clean. In hindsight, I should have done that way before I started the assembly, but live and learn. Now I'm going to do one final wipe, and then we are ready for the head gasket. New dowels. Now we're going to add a little bit of sealant here where the timing cover meets the block. This is per the repair manual. Gonna wipe the numbers. That's seated. Now I've taken all the slack out of it. Very important. New head bolts with washers, and repair manual specifically says not to remove the coating from them. There is a specific way in which we torque the head bolts. We start from 1 to 10. First is 30 Newton meters, and then 90-degree angle twice. So this is number 1. Torque wrench is set to 30 Newton meters. Let's do it. So that's the first round. Now the final round. And that's one cylinder head fully torqued. Done. And that's the cylinder heads reinstalled. Oh, this thing is getting increasingly more difficult to turn. Brand new valley pen cover. For whatever reason, they decided to make it one piece. You cannot just replace the gasket because it's bonded to it. Waste of metal. We have a bolt for the guide that we need to install here. Here as well. Brand new front main seal. Clean the surface. Fresh oil. So there's a special tool to drive it in, which I unfortunately don't have. So you're gonna slowly tap it in. Or simply use the old one. And the seal is perfectly flush all around. Next time, I'm definitely getting that tool. Much less room for error there. The rear main seal we're going to install later once the engine is off the engine stand. Right now the access is pretty limited and that needs to sit 100% perfectly, otherwise it's going to leak. But now we're gonna move on and do the upper oil pan. Looking stunning. Man, this engine is gonna look good. Time to prep the surface. As usual, we're gonna add a little bit of sealant here. New gasket. And for the last time, you have to make sure that there's no slack in the chain. It's not bound up anywhere, because once we put the cover, we're not gonna be able to see it anymore. And now we're going to use some thread sealer on the threads of the bolts. And pay attention, I said sealer, not locker. This is so it doesn't leak through the threads of the bolts. And this is specified in the repair manual. And I can also see some leftovers in these holes here that were put there from the factory. We're going to do the upper oil pan as well while we're here. That way I can just flip the engine over and it's going to stay there until we remove it from the stand, because once we start putting stuff on the top, this is going to be really difficult to turn. I mean, it already is. I could barely turn it over yesterday myself. Brand new gasket and clean parts. Bit of fogging oil for the oil pump. And you can see on the bolts traces of the thread sealer from the factory. By the way, I want to give a shout out to Max from OEMBeamerParts.com. He's a Patreon of the channel, supporting the channel. And not only that, when he saw what was happening with the Alpina, he generously contributed to this build with no strings attached. So I just want to give him a huge thank you. And if you're in the United States, I'm going to leave the link to their website in the description. Give it a look and just know you'll be dealing with really nice people and true enthusiasts of the brand. Oil level sensor with a brand new gasket. The torque for these bolts is 8.5 Newton meters. So I set my torque wrench to 8.6. Hope B&W will forgive me. Oil drain plug. Bit of shine. Because why wouldn't you make your oil pan shiny? All right, so we're done with the bottom end. Let's see if I can flip this thing over. Oh, yeah, that's good. Need longer this thing. Oh yeah. There we go. Now I can install these two bolts here before I forget. Next up, vibration damper, the hub, and brand new crankshaft bolt. We need to line up the hub here with the notch on the crankshaft. Now we need these special tools from our timing set in order to torque the bolt properly. Rotate the engine ever so slightly. So slacking off the bolts. The hub needs to have free movement. New bolt going in. The initial torque is 100 Newton meters, and then we need to do 60-degree angle 3 times. So that's the thing that's going to give us the degrees that we need. There you can see it nicely. We need 60 degrees 3 times. Oh, you're not supposed to see this wheel, but the reason I'm putting this here because I want to support the bottom of the engine because it's held only in the back, and this is a lot of force on the front of the engine. So that's support for the engine. A little bit more. That's one. Oh, so close. A little bit more. That's the second one done. Third one is going to be difficult. I'm going to go see if I can find a massive pipe or something. Found a slightly rusty pipe. This breaker bar, I don't like it. It's just, look at that. That's not going to hold. That's going to snap. And if it does, I'm going to go face right into the studs. All right, found a different rusty pipe. Oh, it does fit. I'm lifting the entire thing. I'm gonna need a second person to stand on the engine stand. It's going. I think we're there. A little bit more. Oh, perfect. Thank you so much, my friend. So that's how you do that. Now I can lock it. Lovely. Time to reinstall the camshafts, and when I disassembled the heads, I took million pictures and also labeled every single part that I removed because all of this needs to go back into its original position. So I'm going to sort this out and then we're going to start. So I labeled every single lifter and all of that is going to go back into its original place. Lifter number 1. Number 2. And that's all of the rocker arms and lifters on bank 1 installed. Oil. Clean intake camshaft with Valvetronic contraption. Now I gotta make sure that all the rocker arms are still in place. Now I need to make sure that these rings are closed and that the locks are pointing up. Like that. So these marks on the cap, LE1, need to point towards the intake. Now I'm gonna slowly do up the nuts from inside to out. Now we're going to rotate the camshaft against the direction of rotation, so anti-clockwise, until these 2 marks are pointing up. Like that. Oil. Clean exhaust camshaft going in. So the lobes on cylinder number 2 here need to point upwards. Again, make sure the locks are pointing upwards. Cap number 1. Again, marks pointing towards the intake. And we have a retainer clip for the oil spray bar here. on the cap number 3 and 5. Same deal, tighten from inside to out. Now we have the eccentric shaft sensor. That concludes bank 1. Now we got to do the same thing on bank 2. New slide rails, new gaskets, and thoroughly cleaned oil sprayer bars. The oil sprayer bars have special bolts that allow oil to flow. Now we're going to install Vanos units with brand new bolts and time the engine. Now I need to pull all of the slack from the chain. Now I need to back out the bolts a little bit. Now I'm going to rotate the exhaust cam until we have marks like here pointing upwards. Actually, the oil sprayer bar comes after we time the engine. So now we can get the tool on the intake cam. The tool needs to sit perfectly flush on both sides. Now we're going to put our tool instead of the tensioner so we can put proper tension on the chain. Now there's no slack in the chain and we can torque this bolt to spec. So we're gonna hold the cam and torque this bolt. You can see the tool sitting perfectly flush on the intake side and perfectly flush on the exhaust side as well. Now remove the tool, and then we need to do the same with the exhaust cam. Brand new tensioner. And that's timing on bank 1 set. Now we're going to repeat the same with bank 2. So in order to make sure that we set the timing properly, we need to make sure that the cam adjuster's Vanos units are in their locked position. On the intake side, we grab the camshaft and try to turn it against the direction of rotation. And as you can see, it's locked. And for the exhaust, we're doing it clockwise. And that too is locked as well. So I'm going to do the same on bank 1 and just verify that's in its locked position. All right, so now we're going to rotate the engine 2 times and verify that this timing is still correct. There she goes, rotating for the very first time. Intake side's good. And the timing is set properly. So I'm going to do it 2 more times, just for fun. Bank 1 intake side, you can see that the tool is sitting flush on both sides. Same dealio, tool sitting perfectly flush on both sides. Bank 2 intake side. Sitting perfectly flush on both sides, and the exhaust. Sitting perfectly flush as well. And that's the timing set. The engine needs to spin effortlessly and smoothly. And it sure does. Spark plug time. First things first, the cylinders are gonna get a half of fogging oil from men. Bob's your uncle. Beautiful timing covers going back in. And the rest of the bolts come later when we install the bracket for the supercharger. And finally, the valve cover with brand new gasket and spark plug tubes. I spent quite a lot of time making sure that is clean, and now we can assemble it. Lubed up spark plug tubes. Last round of sauce for the camshafts. Now you're going to add a thin layer of sealant here where the cover meets the head. And then on the back, what a crappy valve cover to install. So the top nuts are longer and the bottom ones shorter. Tighten them from inside to out. Brand new oil cap. Cheers. Looks good, doesn't it? Didn't look this good from the factory. And that, ladies and gents, is a fully rebuilt Alpina H1 V8 engine. Pretty proud of myself, not gonna lie. Let's just hope I did everything correctly, and when the starting time comes, it's gonna run properly. I had properly good time doing all of this. It was really interesting, great learning experience, and I do hope that you also enjoyed this episode and learned something as well. And to be honest, I wouldn't mind doing this again on a different engine, not this one. But there's actually a lot more stuff that needs to be bolted back before we can remove it from the engine stand. Then the transmission needs to be bolted back, cats that are somewhere, and then all of this goes back into the car, and then a million other things. And we're gonna save all of that for the next episode. Hopefully then we're gonna go for the first start as well. I'm gonna finish my beer, go home, and savor the moment. This was a big one. As always, thank you very much for watching, and if you enjoyed the video, please consider subscribing if you haven't. I would appreciate that, and I'll see you very soon.